So the recording has been started. All right. All right. Okay. So before we go ahead, do you have any questions for me? All right. So far we have talked about what is big data, and then we talked about SDFS, yarn, MapReduce, then how to write pig Latin that gets converted into MapReduce, then Hive, and then how to handle velocity. That's what we talked in HBase. All right. So today we are going to cover 2, 3 more components, which are peripheral components, which are used from time and again. And it's important to know these components when you are dealing with the whole ecosystem of big data. All right. So today we want to talk about Zookeeper, Scoop, Flume, and Uzi. All right. All right. Before we jump into Zookeeper, do you have any questions for me? No? All right. All right. So should we start our discussion on Zookeeper? Wonderful. Wonderful. Okay. So let's talk about Zookeeper. Okay. So let's say that you have many machines and you want a coordination between them. For example, in case of email processing, let us say that you have an inbox which need to be processed, as in emails are coming into the inbox continuously. And what you want to do is, on every email processor, you want to say index the email. Now, what would you do such that these email processors do not index the same email at the same time? Okay, meaning one email should be processed only once, and email processor does not have ability to modify the inbox, but every email has got identity. So every email has got identity, and this inbox is read only. Now, question to all of you is that if this kind of system has to be built, there would be a need of a strong coordination between various email processors. Had this process being done inside a single thread, it was very easy. But if there were multiple thread but single machine, it was very easy to use the programming language specific constructs to, such as threads or semaphores, to avoid multiple threads trying to access the same data, right? And had it been different processes on the same machine, we could have done the coordination using, the local file. All right. Leeladhar is not able to hear me. Okay, let me just Leeladhar, everyone is able to hear. Please check the settings. All right. So, so in scenarios where there are multiple machines requiring the coordination, you would need a central system, correct? All right. So, so what will be your solution to this kind of problem when you have multiple machines trying to index an inbox which is read only, but each email is identifiable, has got an ID. Now, what will be your solution to enable the coordination? Anyone? Yes. All right. Are we all on the same page? Babu, Christine, Dheer, Hank, Hari, Harsh, Jayaprakash, Kamal, Leeladhar, Madhu, Michelle, Pankaj, Rana, Rebecca, Sabanand, Dabral, Shashi, Swarn, Venkat. All right. So, okay. So, my question is that if you have to build such kind of architecture, what would you do? Question is that you want to process emails from an inbox without without processing same email multiple times on multiple processors. Okay. And you are not allowed to modify inbox, but luckily every email has got an identifier, unique identifier. How would you build? Quickly? Christine says partition processors by unique ID ranges. That's right. But partition as in, if this inbox was static, partitioning statically was possible. But more and more email keeps coming and email processors keep running all the time. All right. So that sorting logic, another problem with the sorting is that we will have to use a separate logic, as in separate machine or separate program, which will do the sorting and inform the email processors. Okay. All right. And such kind of problems are very common. Earlier, when we had this kind of problem in a single process, we used threads, logs, or monitors or semaphores in a program. All right. But in case of distributed computing, where you have many processes running on many different machines and they want coordination, what do? Yes, each email should be processed only one. That's correct. So Babu says that we could use messaging queue. Interesting. Rebecca says integrity check on unique identifier. That's good. That's good. All right, so that's what we are going to do. The coordination generally is done in this manner. If you remember, let's say there are 20 salespeople, and and they are making calls in a room. So what do they generally do is they have a big whiteboard, and whoever is making a call, the person will go ahead and mark that I'm calling this particular company on the whiteboard so that other people do not call it. All right. Similarly, here these email processors would write on a common whiteboard, whereby they will mention that this particular email ID I'm going to this particular email I'm going to process. And before doing that, it will first check if somebody is processing it. If nobody is processing it, then it will mark that in on the whiteboard and then start processing it. Second one will come, pick up the second email and mark it here, and so on. So this way, they can do the processing in a very, what do you say, in a very parallel way, without having to divide the work upfront. So this is synchronization. That's right, Jayaprakash. So this is synchronization in a distributed environment. The question is, what happens to this whiteboard? Is it some kind of a file, some kind of a database, or what is it? Because it cannot be file, because it has to be processed parallelly from remote. Okay. Also, files are only append only, therefore it's quite cumbersome. And in the whole scheme of things, Zookeeper is this whiteboard. Zookeeper is a place where everybody can create the data and check the data and so on. So Zookeeper is a centralized kind of a whiteboard where various processes, where various programs can come and write their name or create their data. All right. So the utility of this whiteboard is clear to everyone. Very good question, Michelle. So yes, it is kind of in RAM, and yes, this is a very good question. Her question is that is it in RAM? So yes, because, and you will see that in the design of Zookeeper that it does keep it in the RAM. All right, brilliant. So all right, so this is where Zookeeper comes into play. Zookeeper provides you a simple set of primitives which are very easy to use, and it provides a data model like directory tree. Okay, it could have provided you a list kind of interface or something like that, but Zookeeper realized that the easiest and most flexible system to manage is the directory tree. Okay, it could have been like a phone directory, but they realized that um, it's better to have the directory, no, sorry, the tree form rather than a hash table for these kind of use cases. It is used for synchronization, and it is used for configuration maintenance, and it's a coordination service that does not suffer from race condition or deadlocks. Okay, so Jayaprakash is saying that it is kind of Hazelcast. All right, let me see if, let me try to understand what does it mean by Hazelcast. All right, so Hazelcast looks like a database which runs in the memory. Okay, so it's kind of, yeah, it's so Zookeeper is not like a hash map in a distributed fashion. So Hazelcast is more like a NoSQL in the memory. Here, the Zookeeper is almost like NoSQL. You will find the differences very soon. Okay, why you cannot use Zookeeper for storing data? You can only keep Zookeeper flags in the Zookeeper. Very boolean, very small data. In Zookeeper, you can only keep very small data. All right, you will see that. So installation is something. All right, so this is how the data model of Zookeeper looks like. Meaning, these are the nodes that you keep on creating. On the top there is slash, just like Unix file system. It has this model. The only difference is that every node can contain small data in the JSON format. Okay, every node has got a name and has got some data with it. All right, every node can have children, and except for the root, every other node can have the parent. All right, so it's very much like a file system, but unlike file system, it doesn't have concept of directory or file separate. These are basically nodes in this tree. Every node kind of can have the children and has the parent. All right, so you store the data on every node. Okay, so the name of the this particular identifier of the node is /zoo/duck, meaning /zoo/duck. So this is the duck, and it can contain some more data. All right, before we jump into the hands-on, I will try to explain the three kinds of nodes. We call them Z nodes. Okay, these are called Z nodes. Kamal is saying the Zookeeper is used for adding and removing nodes to a cluster. Not really. Okay. It is used for load balancing. I'll show you that. But this node has nothing to do with the machine. It is just like a file. All right. It is just like a file. All right. All right. A question from Sabanand is that can you give an email example on a tree node? Yes, I'll give you in a minute. Okay. Now, so the data model looks like this. All right. So before jumping further, I think it's better to do hands-on now so that I can explain the other parts. All right. Let's all of us log in into console. Okay. Let's log in into console. Let me also open the console. You can also I'll just go to my courses, and from there I'll go my courses. Oh, it has logged me out. Not this one, sorry. This one doesn't have CloudX Lab yet. All right. All right. So is everybody able to log in into the console? Yes, great. Hank, the console is not opening for you. All right. Most likely the copy paste may not be working, Hank. You could try either typing. Okay, I'm waiting. All right. Is it saying login incorrect? All right. Is anybody else facing the issue logging into the console? Yes. Everybody able to log in? I see only 6 people have logged in. Not 6. I can see around 11 people logged in. Yes. All right. All right. Okay. So Zookeeper, to interact with Zookeeper, we are going to use a command called zookeeper dash. All right. I'll be a little slow. Okay. I typed zookeeper dash client. You might be wondering, how did I type so fast? All I did was I typed Z and pressed tab. Okay. So it auto completes, and that's why I was able to type quickly. Okay. All right. Good. Is everybody able to log in here? Does it show you ZK connected? All right. Okay. So Hank is facing a problem of cursor not moving. Okay. If you don't mind, yeah, I can help Hank quickly so that we all are on the same page. Okay. All right. Hank, do you mind if you share the screen and I can help you with it? I'm actually wondering why it's not working. Okay, it says that timed out. Okay, Hank, can I give you a quick suggestion? Um, this console doesn't seem to work so great on the IE. Is it possible to use Chrome? I think that's the problem. It's nothing wrong with you. It's just Chrome, the IE problems which I have. The console suffers from the IE problems. All right, Hank. All right. So try with Chrome. Most likely, you can actually you will not face any kind of problem as such. All right. But I would strongly suggest that you log in into Chrome and then try again. Okay. Do you have Chrome? No. Or you use Putty for time being. If you have Putty, you can use that. All right. Swan's question is: separate Zookeeper server is required to store states or log. Yes, I will show you. Okay. What does it mean by server? So I'm again logging into the Zookeeper client. Now, when you say ls, can you see all kinds of nodes? Okay, these are the various kinds of nodes created by various processes and people in the class. Okay, so here we could also say, okay, create, what's the name of the class today? Let's call it 27 August. Okay, and KBD class, that's the data. So here I'm saying, okay, create 27 August at the root level. So you have to type Zookeeper client. Thank you, Christine and Rebecca. And all right. So okay, let me also take it to the top. This is better, I think, for everybody. Okay, and say create 27 August. So I'm creating a top level folder just above below root, and I'm putting this data here. Now, when you say ls, the same will be reflecting to all of you, right? You can see that. Can you see in the list here, 27 August? When you say ls/l, are you able to see my node, everyone? Okay. On your console, if you type ls space slash, you will see all the list, and there is your node. If you want to see what is there inside this particular node, you can say get, and here is the data. Okay, so you have got this structure under which you keep on creating these nodes. Yes, this is shared between everyone. Whether you are on E or F or G, you will be able to see the same thing. Okay, although E, F, and G, they are three different machines, but this should be visible to everyone. Okay, unless there is a problem in the network. Let me log in into F. Okay, just to validate if what I said makes sense, because as per my understanding, we had set up this node in a way that everybody can access it. Okay, I'm logging into F. All right. Oh, it doesn't allow me to log in there because they haven't created my account there. Okay, who is on E or who is on F or G? Michelle, you must be on F or G. Is there anybody on F or G? Instead of e.cloudxlab, do you see f.cloudxlab in the console?
No? What is your console URL? All right, great. So yeah, so Rebecca is on F. So Rebecca, are you able to, when you say ls slash, are you able to see 27 August, the one which I have created? Yeah, great, great. So the point is that even though we are on different machines, we are able to see the same data structure, which means Zookeeper is uniform for all of us. Okay, so that's the first point and most important point to understand, that it is basically kind of a central database. All right, now let's move ahead. Now the node that we have created called 27 August, and we have added some data on it. It is called a persistent node. Why do we call it persistent? Because even after I exit, it will remain there. While there is another kind of node called ephemeral node that disappear as soon as I log out. Okay, so there is ephemeral node that disappears as soon as I log out. Okay, that's correct, Jayaprakash. If multiple users are creating different data or updating different data for 27 August, last updated value will be there. Yes. So Swan's question is, slash 27 August, is this is a folder or node? Actually, in Zookeeper, there is no difference. There is nothing called a folder. Everything is a Z node. Okay, that's the difference between usual file system and Zookeeper's data structure. Okay, so the way we keep all right. So this question is, how does Zookeeper fit into Hadoop ecosystem? I'll explain. Let's just stay with it. So Zookeeper is kind of an independent system, and it's a very, very important component. Ideally, we should start whole Hadoop class with Zookeeper. Okay. But for the legacy reasons, I generally start with Hadoop, but we should be starting the whole class with Zookeeper. Right? Now, coming back to it, and all right, so these ephemeral nodes disappear as soon as the session ends. Okay, let us say that I create an ephemeral node. I create an ephemeral node uh, under 27 August. Okay, I call it my EPH. Okay, this will disappear. Okay, so I've created this ephemeral node. Now, when I say ls slash 27 August, okay, 27 August, okay, it makes a difference. Now you can see, all right. So thank you, Hari, for reminding me that. So now you can see that when you say ls slash this, you see my EPH. Now at this point, if I get disconnected for some reason, okay, if my internet get disconnected or I close the console, this particular ephemeral node will disappear. All right. So how did I create this? I used this command. You can give a different name. Okay. You can, instead of my EPH, you could give your, okay, your node name and create ephemeral node. Okay. And let me check if it is this appearing here or not. All right. Now, I have exited the Zookeeper client just now. I pressed Control C. I came out of it Now, after a while, that particular ephemeral node will disappear. Okay, that particular ephemeral node will disappear. Right now, it is there, but in couple of seconds, it will disappear because the shell that was connected, the cell that created this particular node has disappeared. Okay, so you can see that my EPH has disappeared. Did it make sense to you? All right, so we can actually keep it like an attendance system. If I have to make sure that all of you are connected, I'll ask all of you to create ephemeral node. And the moment, as soon as your system get disconnected, your nodes will start disappearing, or your ephemeral nodes will start disappearing from the folder. Okay, so I can actually track the attendance, who all are connected, who all are continuously connected to the system by monitoring the list of ephemeral nodes. Okay, so we created two kinds of node, one normal node, 27 August, for example, and then I created an ephemeral node which disappeared when I disconnected the shell. All right, is everybody with me on this? So persistent node remained there while ephemeral node disappeared. Any doubts about the persistent and ephemeral nodes? Now, you might wonder what's the point of this ephemeral node? What is the point of this ephemeral node? So Sasi's question is, the ephemeral node is on RAM and persistent is on RAM? No. So both are, storage wise, both are in the RAM and both are in disk. Okay. The storage does not differ. What differs is the lifespan of the data. Okay, if a if a client disconnects, the data will disappear if the data is ephemeral. All right, and so on. All right, now, so let's take a look at what happens. This is a very important aspect, and I wish I should have done it earlier. Okay, so let's say that there is some what do you call top level node called name node. Okay, name nodes. Okay, there's something called name node. Okay, this is one of the parent node. Now under this, let's say one machine comes up. Okay, and yeah, under this one machine comes up and they, what is the best way to draw? I'm not good at it. I think I should just use my usual one. I am good with that. All right, so I'll just use my usual. All right, so yes, so imagine that there was a particular node, let's call it slash name nodes. Okay, that was our top level name node, under which, let's say whosoever is coming in, let's say there is um, IP address called 192.168.1.100 came in. Okay, and it created a child node. It created a child node. Similarly, some other machine came in and they created their own node, let's say 101, under the same machine. Okay, let's call it that this one is name node and this one is let's call it standby. Okay, so the way the dynamics work in case of name node and standby is alive name node comes alive, creates a children node here under name nodes, and then if there is already a child node and that one is marked for live, it will mark itself as standby. Similarly, so all kinds of name nodes, no matter how many of those are there, they will mark their attendance by the way of creating a formal node under name nodes. Let me show you this part. This is a very important part. I'll show you this part in case of HBase. In HBase, there are multiple region servers, and the way HBase master discovers its region servers is by the way of zookeeper. Okay, it's by the way of zookeeper. I'll show you this. So if you say ls slash, do you see HBase unsecure? Okay, so you can see this. There is other data such as rs. Okay, so under this particular nodes, there are ephemeral nodes. Right now, there are only two region servers, and these two region servers created these two ephemeral nodes. All right, does it make sense to you? In case any of these region servers die, after a while, this particular Z node will disappear from it because it is ephemeral. Ephemeral node disappears as soon as the network gets disconnected. All right, network connection get disconnected and ephemeral node disappears, and that's how HBase master keeps track of how many region servers are available as of now. Okay, do I make sense to you? So Hive server, HDFS, everybody, right now we have not configured our HDFS in the complete load balancing way, in the high availability way. Otherwise, there will be HDFS node here that would contain list of all the name nodes available to as a standby. All right. Question from Christine is that how can you tell by looking at a Z node that it is a persistent or ephemeral? That's a good question. So let's take a look at if you say get, somebody was asking how do you get the data about a node? Okay, you can type get and the node name and you will get this. Okay, all right, now here you can see that in case of non-ephemeral node, ephemeral owner equals to 0x0. Okay, what does it mean? meaning it is not an ephemeral. Yes, that's correct, Dheer. All right. And similarly, if you let me see if anybody has created. All right. So I think everybody has created. Okay. What I'll do is I'll just decrease the size of my console, or let me take out the window. Okay. I've taken out the window and I'm trying to resize it. Yeah, that's better. Okay. I think you'll be able to see it now. Good. Now you can see that. ls this, and okay, let me take a look at, let's say, tk test. Okay, so there it shows that there is ephemeral node, ephemeral owner. All right. Jayapraka's question is, what comes under non-ephemeral node? Non-ephemeral node is basically a persistent node, the usual one, which does not disappear even after I disconnect. Okay, generally the parent nodes are kept non-ephemeral because ephemeral cannot have children. All right. Similarly, let's take a look at the Christine's node. All right, you can see that. Good. This question is, when I created data, I gave a long text. So you have to give JSON format data. So the data can only be JSON format. All right. So make sure you put, and by default, a string or a number is a valid JSON data. Therefore, it's accepting the data as valid. All right. So keep that in mind while providing the long string. Long string is not a valid JSON data. Okay. Now the third kind of node is a sequential node. Sequential node is based on the philosophy that when we create a node in the Zookeeper, it has its running count. It has its running count. All right. So whenever a sequential node is created, we only provide the prefix, and it automatically adds a number as suffix. Okay. So let me show you this. Let me show you this. So we have ls and ls 27 August. You see this? And here, if I create a ephemeral node, sequential node, I just have to provide a prefix, and automatically it'll create um, a sequential node. Let me try again. 27 August, and the I forgot to provide some data. Okay, so you can see that it has automatically given it a number 15, because probably so far 15 nodes must have been created under this. Okay, so basically this number automatically that is given to a children is the running count of total nodes created so far. Okay. All right. So similarly, if let's say I'm creating a fresh nodes, okay, I'm creating a fresh node, okay, I'm calling it sequential parent. All right. Now, if I create a sequential node under this freshly created node, it will start. It will start with okay. It will start with 0. right? So this is a third kind of node, all right? Every node has a running count of children, running count of total number of children. And this running count basically is suffixed. This running count combined with the prefix provided by the user forms the name of newly created sequential node. We cannot create inside another Z node inside a formal Z node. That's correct, Kamal. Okay, is everybody with me so far? Now, problem with this question that people ask generally is that what's the point of sequential node? What is the point of sequential node? Sequential node is used in different kind of coordination. All right. If you remember, if you know that in a what do you call um, so so let's say there's a ticket tracking system you are building. Let's say when you send an email to CloudX Lab, it automatically assigns you a new ticket. And when this number generation, automatically ticketing ID, or let's say issue tracking system, bug ID, and so on, when this number system becomes complex, as in there are many clients trying to generate a sequential number very frequently, in those cases, this uh, this sequential node comes into picture. Okay. All right. So Jayaprakash is saying sequential node for series of MapReduce job. You can create if your job can basically access Zookeeper, and you can utilize the sequential node in that. So Kamal, was I able to was I able to give you a good use case? It's not a random counting number. It just sequentially, it's monotonically increasing number. And imagine that under a folder, me, you, and everybody are trying to create sequential node. My question to you is, will it make mistake or will it be okay? Okay, so I want to do this experiment. Uh, uh, okay, uh, Rachel, Michelle, and others who are on F or G, they should also try executing this parallel to me, and let's see if it conflicts. Because the sequential number is very useful thing, because if there are many users parallelly trying to create a sequence number, and this is a very tough problem to solve. If there are a million users continuously trying to generate a unique monotonically increasing number. All right, is anybody trying to do this parallelly? See, it's generating unique for all. All right, so I can show you this. All right, so you can see that it basically, even though we are logged in from different machines, still it does not conflict. I think other users are also trying to do this. All right, so you can see that it is monotonically increasing. And also, even if I give here XYZ instead of a prefix, the sequence number remains in the same way. Good. And also, if we delete all the previous ones, still it will keep on continuously increasing. It won't start again from 1. All right. Why? Because every time a node is created under a node, it keeps track of how many nodes have been created so far, and based on that, it gives a new node ID. All right. Okay. So you can see it's basically increasing monotonically. Even though we are logged in from different machines trying to create sequence number under same node. Everybody with me on all the three? Was I able to convey the sequence number? Was I able to convey the utility of Zookeeper? Who all got the idea about who got? Do you think it is a useful tool? Christine says, "Is this all Zookeeper does?" Yes. For the end user, these are the basic use case of Zookeeper, and using this, all kinds of components in the Hadoop ecosystem, whether is the load balancing between name node and standby, meaning not load balancing, it's switching between the two. We talked about earlier, we earlier talked about how standby works, that name node goes down, standby takes the place. How does that whole dynamics work? The whole dynamics is based on the fact that name node and other name node mark their presence inside a Zookeeper Z node. Okay, they write their name inside a folder in a Zookeeper. Okay, and that's how they mark their presence. And these nodes, when they create their presence, generally they mark it ephemeral, so that in case the nodes shut down, the information that they gave about them, the presence marker that they have marked earlier, will disappear. Okay, so that's how the coordination happened. The coordination between uh, the HDFS name node and standby, the coordination between HBase and its region servers, the coordination between Kafka queue. We will talk about Kafka and brokers, and you will be amazed at that the fact the Hive server itself is load balanceable, and all of these components use Zookeeper to to basically coordinate between their various instances. Okay, Hive, HBase, HDFS, and other components, even the Kafka, they all use Zookeeper for coordination. All right. A question from Dheer is, do MR, HBase, HDFS use internal Zookeeper? It's the same Zookeeper they are using. All right. It's the same Zookeeper that we are using right now. You can take a look. Okay, you can take a look. You can see Hive server. There are two Hive servers. All right, let me show you. All right, inside Hive server, you will see the comma separated data. This is first Hive server. This is second Hive server, and this is third Hive server. There are three Hive servers running right now. Zookeeper is automatically installed when you are installing Hadoop package. Okay, it comes with Hadoop package. That's right. All right. So everybody with me on this so far, should we move ahead? So apart from this basic concept, no, you don't have to install Zookeeper separately. In case you're not installing, if you're installing Hadoop by yourself, as in using the plain vanilla Hadoop from Apache, instead of using Cloudera or Hortonworks, if you're using plain, then you might have to install Zookeeper by yourself. Michelle's question is, are there always two levels, or there could be more levels in certain cases? There can be many levels, as many levels as you want. All right. I'm not sure about the restriction of the labels in the node structure, but I haven't so far come across a limitation. Okay. All right. So now we are all able to create this. Now, the one important thing that I wanted to discuss, which we have not discussed so far, is the architecture like Zookeeper. Okay. All right. When we created name node and data node, who designated that a machine need to be name node? Us, or it got automatically designated? Yes. Who can answer this question? When we created name node and data node, who designated the machine to be name node, not data node? Us, admin, right? That's correct, Deep. It's the admin who did that. It was done manual. Yes. Now, in the cases, the zookeeper is very interesting because in this, the master is designated based on a political system amongst the nodes. Okay, and that's something very interesting. It's called, some people call it whisper protocol, and some people call it the we will, what do you call it? I am forgetting the name. Uh, Paxos algorithm. People call it Paxos algorithm. Okay. All right. So if somebody asks you after this big data class that what is Paxos algorithm, you can explain to them. All right. And the purpose of this is that this is a very interesting phenomena as how machines designate another machines as master, and how they basically dethrone the master and make somebody else the master. You will see that. I'll explain to you. So architecture is, one is standalone, which is not used anywhere, uh, and other is replicated. In replicated, Zookeeper runs on many machines. The way right now we saw that Zookeeper was actually running on multiple machines and coordinating amongst it. Okay, so yes, HA means high availability. That's correct. And so the the architecture which is commonly used in case of Zookeeper is the high availability, because Zookeeper is heavily used component. In case Zookeeper is out of service, uh, all other services will not be able to run. Therefore, replicated or HA, highly available, is the only way forward. So it runs on a cluster of machines called Ensemble. So we install Zookeeper on all the machines. We inform the Zookeeper, all the machines, about all other machines. Okay, every machine knows, every Zookeeper knows about other machines on which Zookeepers are going to have been installed, and then we turn them on. We start Zookeeper parallelly on all the machines, and then they start voting for each other and select a leader amongst themselves. All right. So the first phase is leader selection. We call it Paxos algorithm. The machines elect a distinguished leader, okay? Distinguished member called leader. So you can see that in, so so the way we have looked at Zookeeper so far is that, okay, there's a file system kind of thing, and we just started Zookeeper client. It connected to some server internally, and maybe we are reading the data from there. But internally, we, me and others were reading the data from different machines. Okay, because because reading can happen on many machines while there is only one machine called leader where writing happens. When we say create any node, the request goes to the leader. Okay, create, delete, update, set the data, and so on. All of these change requests are forwarded to the leader. Why do we forward all the modification requests to the leader? Is because if there are multiple people accepting changes, there are high chances of inconsistency. All right. Now, these servers, these zookeeper services, vote for each other on what basis? One, who has the latest data. Second, who is responding well to the pings. Okay, these are the two major criteria for selecting a leader. Okay, so the node which has the most recent data is the leader. And so so basically this phase finishes as soon as the leader is elected. And if the leader fails, leader is dethroned and election is held within 200 milliseconds and somebody else becomes leader. Okay, if the majority is not available at any point of time to the leader, leader will step down. This is a very interesting phenomenon, and this is common with MongoDB and other systems. Wherever there is this replicated model, everywhere, as soon as there is no majority, the leader steps down. Majority as in, right now there are 3 machines in the network available for voting. Out of 3 machines, if less than 2 machines or less than 1.5 machines are available, 1.5 or less machines available for voting, the leader will step down. Okay, this is a very critical part of very critical part of the voting system. So Shashi, this is not machine learning. We'll talk about machine learning later. It sounds like machine learning, but it is very it's just an intelligent algorithm, and it's a coordination algorithm. So these machines voted for a leader. Leader will step down in case there is no majority available at any point. If out of 4 machines, if 2 machines die, there is no majority because 2 is not bigger than half. 2 is equal to half of 4. Therefore, majority means bigger than half. Yes, if there is no leader, if there is no leader and there is no leader selection possible, then the whole zookeeper will become read-only. All right. Now, question is, if you have 3 nodes A, B, C, A is the leader. If A dies, will somebody become leader? Quickly, that's correct. Yes, it will become. If A dies, there are 2 machines remaining. 2 is bigger than half of 3. There are 3 nodes. What is half of 3? 1.5. 2 is bigger than half. Okay. So either B or C will become the leader. All right. All right. Do I make sense, Christine? But 1 doesn't exist, so there's only 2. Yes. So 1 is dead, which means 2 out of 3 are available. Because as I told you that all 3 A, B, C in the network, we have configured this network of zookeepers. We have informed all of them that, hey, there are three people in the network. There are three zookeepers. All three of them know that part. In case A drops out, still it will keep all of these people will know that they are having one person absent. Okay, so at this point here, if B drops out, if A drops out, B or C would become the leader. Now, question to all of you is that when A died, okay, A died, C became the leader. When A died, C became the leader. Now, what if B dies? Will C remain the leader or will it step down? It will step down. That's right. C will not remain the leader and it will step down and the whole system will become the leader. Majority is not available and C will become just a follower and providing only the reads, not the writes. Okay. Question is, why is it that we need majority? Can anybody help me with this? Why do we need majority for leader selection? Let us say we had, if you take a closer look at it, if you had 100 servers and 50 died, will there be a leader among remaining 50? Don't you think that you are all right that there won't be a leader amongst remaining 50? There won't be a leader selection amongst remaining 50. Why is it so? Why are we wasting 50 nodes? 50 nodes is a decent size. Okay? 50 nodes is a decent size and we should be utilizing those while we are not. Can anybody help me understanding that? Anyone? That's correct, Christine. Maybe it's telling you that something is really wrong and it needs immediate fix. That's correct, Kamal. It can go out of sync. Let's try to think over it a little bit. What could go wrong if election happens with the remaining 50? What could go wrong? Something very disastrous could go wrong if remaining 50 held an election and chose a leader. If remaining 50 chose a leader, what kind of disaster could happen? All right, let's see what kind of disaster could happen. Let's imagine that you had two data centers. In this cluster, you have only 6 nodes because for the simplicity on my slides, I've kept only 6 nodes. Now, the interesting part is there are two data centers, data center 1, data center 2. In one data center, there are 3 machines. In another data center, there are 3 machines. And all these 6 people have chosen a leader A. All these 6 machines have chosen the leader A. Correct, Kamal, you got it right. All right. Now, what happens when there is a disconnection? There's a disconnection between the two data center. ABC form one island and DEF form another island. Now, if both of these A, B, and C, if both of these islands start having their independent election, they will have different leaders. Okay, imagine having this scenario that there are two leaders, A and D, both A and D accepting the changes, right? Some customers are talking to A while some customers are talking to D, and both of them modifying the same data, and the data is going in two different directions, right? On leader A, the same node has been deleted. On leader D, same node has been updated, modified, and changed. One client came to node A, and another client came to node D, and it'll be a disastrous because consistency is gone. It is reconcilable. We cannot reconcile such kind of changes. When I talk about here, I'm talking about machines. Okay, earlier Z node was just a conceptual, the software. Here, A, B, C are basically physical services running. All right. So is everybody with me on this so far? No? Okay, good. Kamal? Kamal got the right answer. Good. And earlier. All right. So that's why this is a part of these kind of complicated scenarios are taken care by implementing Paxos algorithm correctly. There are many more challenges when you think about distributed election. You will think about like who will keep the count of votes, who will keep the what if they start cheating with each other, if somebody starts start giving more and more votes to each other, and so on. This whole complication, the dynamics, because whatever is the behavior of one zookeeper, it will be the behavior of all other services as well, the identical behavior. Okay, therefore the Paxos algorithm's design is very crucial for the design of any highly available service. Hank's question is why leader and follower need in Juno Zookeeper? That's your question, right? Why do we need leader and all of this? Correct? Right. So, all right. Let me deduce it slowly, one step at a time. Okay. Yes. If there are multiple yeah, so if there are multiple nodes talking to one machine, then it's a disaster. Oh, sorry, if there are multiple leaders, it's a disaster. Okay, okay, let me try to answer this. So if there is one machine, okay, one machine meaning no HA, correct? If there is one computer accepting all the changes, then no highly availability. Correct? Everybody with me? Now, if there are multiple machines, should all machines accept changes to the data? Hank? No, right? Then only one machine should accept changes. Correct? And distribute the changes to all. Okay, question to all. Should all machines accept the read requests. Yes, correct. The all machines should accept the read request. Why? Because because number one, read requests are read requests are very high as compared to changes. Okay, generally in the ratio of 1 is to 10, 10 is to 1. Second, second, it is generally okay to have little older data because these kind of systems have eventual consistency because from master till other machines it takes some time to reach the data, reach the changes. As I was demonstrating that I made certain modification, but those modifications reflected to Michelle after a while, Rebecca or Michelle. So I missed the name. So the changes took some time. So there was eventual consistency, not immediate consistency. All right. So, all right. Now, which one should become the leader? So far, in case of name node and HBase, name node and HBase master, we ourselves marked a particular node. We did a year marking ourselves. The admin did that. Okay, but that's not a good idea because in case a node goes down, there is a human intervention required to bring it up. Therefore, automatic failover is required. All right. I hope I have been able to explain to you all of this. So number one, you can build your own highly available service using Zookeeper. The way Hive right now is coordinating between Hive servers using Zookeeper. You can also build that by the way of using znodes and ephemeral znodes. Okay, persistent and ephemeral znodes. All right. Second, you could build a configuration management system. All right. You can build a central locking system for stronger consistency. Is everybody with me on this? Kamal's question is, so system will start electing a leader once majority of the system is available? Yes. So what process keeps checking this majority? All the machines keep checking this majority. The election keep happening every 200 milliseconds. So for a deeper dive, I would recommend those who want to really understand what goes inside it, they should take a look at Paxos algorithm. All right. Christine's question is, in your email processing example, the point was to not put the same email on multiple servers, but how is replication handled? If follower B goes down, where is the data? All right. So see, let's say A was handling the data. Okay. All right. I'll explain what does it mean. Yeah, I'll try my best to do this. So let's say there was a whiteboard. Let's call this Zookeeper. Okay. Let's call this Zookeeper. There is a machine called, let's call it Okay, there are these three machines. Okay, what these machines do is when they want to process something, they write their name. Okay, they write the ID of the email, let's say 1 and comma 1. This name is 1, 2, 3. So first ID is being processed at 1. Let's say third one is being processed at 2, and 50th email is being processed at 3. Okay. Now, as soon as third one finishes, it'll go here and will mark it, kind of either remove it, that I am done with it. We don't need to process. Nobody, I mean, need to worry about it. Okay. So basically, the ephemeral nodes will represent what kind of data these nodes are processing. Okay. In case 2 goes down, okay, that means the result that 2 was supposed to process did not happen. Therefore, this third one needs to be processed again. And therefore, if this goes down, this disappeared from it, and somebody else can work on the same data. All right. I'll have to get into a little bit more detail to explain to you that the coordination, the instant coordination is very much possible using ephemeral node kind of model. That's right, Christine. So data always, so you never store data uh, in a never store big data into Spark, not into Zookeeper. Why? Because every node in the cluster will have the whole copy of the data. Every node in the cluster will have whole copy of the data, and not only the whole copy in the disk, but in the memory as well. Okay, so it's not a great idea to have whole data to be in the memory. All right, so there are APIs available. Okay, there are APIs available to modify Z nodes, and there are very decent API available in all kinds of programming languages to talk to Zookeeper. All right, and so, all right, now when not to use Zookeeper to store bigger data or decently bigger data, not huge data. Okay, and because number of copies of the data is equal to number of nodes, and all the data is in the memory also. Therefore, along with that, there is a network load of transferring all the data to all the nodes. Okay, and if you are not okay with eventual consistency, you should not use Zookeeper, because it does not provide you strong consistency. It only provides you eventual consistency, but it's very decent speed. All right, so that was our Zookeeper discussion. This was very important topic, so I had we could not, say no to it. All right. All right, so any other questions before we jump into our usual discussion, the next topic? Yeah, no questions. So, all right, I'll just give you the definition of scoop. If you are looking for a deeper discussion, you could actually take a look at the scoop. Okay, so scoop is basically for pulling in the data from your databases, MySQL or others, into HDFS, Hive, or HBase. Okay, so you could use scoop command. Scoop is not a server, it's a command. So you could use import and import data and so on. All right,
So if you, I'll just take you through this quick exercise. So whether MySQL, Oracle, or MS SQL, you could import data from there into HBase, Hive, or HDFS. Okay. Also, once you have imported data into HDFS, you could import that into Hive. All right. So first you create data into MySQL, temporary data. This is just temporary data. Then uh, create this is a temporary database which we are creating, giving privileges to all the machines to access the data in MySQL. Why? Because when we run a scoop command, the scoop command gets converted into MapReduce. Okay, a single table from MySQL gets imported by multiple maps running on multiple machines. Therefore, you never know which all machines, which all node managers will be talking to the same database. Therefore, it is wise to allow all the nodes in the cluster to access this database. Okay, so we give the privilege, we create a database, we give the privileges, and then we create some sample data in the MySQL, okay, in that database that we have created, and then we use scoop import command, and then using scoop import, okay, we are telling the login password of the MySQL user. These are the MySQL user login password, and then we are specifying the URL of the MySQL. We are telling this is the IP address of the MySQL server, and this is the database that we have created earlier, and the table name is this one, and we are saying import. Also, we are specifying -m2. What does it mean? It means that import data using two mappers, not one mapper, two mappers. All right. And once that's done, it will create a folder called widgets in your home directory, and there'll be the files inside it. Okay. So when we say scoop import, this particular database, from this particular database, this particular table using two mappers, and the login password for MySQL is this. And on what basis the work should be divided into MySQL, into the various mappers, is based on the ID. Okay, based on this particular column. So some of the IDs will be imported in one mapper, some of the IDs will be imported in another mapper. Okay, so you can see that this is the command that is to be used for importing data. All right, a quick question: do you need reduce phase in the? Will there be any reduce phase when we are importing data? That's correct. That's why you see part dash m. Because here all the mappers are running parallelly, and mappers can have Java code talking to, and it basically is a Java code which will import data from the, it'll import data from MySQL. From MySQL, every machine has been designed for only importing certain data. And why do we need a scoop instead of your own script? Because scoop can handle huge data, right? All right. So this was how to import in HDFS, and this is how you can create a Hive table using scoop based on your MySQL table, and this is how you can import the data from MySQL into HBase. You will have to define, you have to tell it that this is the column family I'm importing data to. Okay. Also, you have to mark which all columns you want to import. All right. Also, you will have to define a row key, because the difference between MySQL and HBase is one, every table must have the ID, the row ID. Second, Column family need to be defined. Okay, so will a new schema be defined in HBase? No, you will. No, actually, the column family will be created in case it doesn't exist in HBase already. That's how it works. Okay, column family will be created if it doesn't exist, and columns will automatically get added. So you don't have to really define HBase table before importing. All right, so this is what is the mapping between the two. Also note that in a single scoop command you can only import to one column family. In the second command you can define another column family, and the other columns will be imported into the another column family for the same row IDs. Okay, will scoop also work with NoSQL database like Cassandra? Answer is no. The other database, the source need to be JDBC compliant. All right, so you can try at your own pace. Okay, there are very good examples from my another class that should help you a lot. Okay, from MySQL to Cassandra, no, actually only Hive, HBase, and HDFS is what I've seen the commands for. Okay, if you go into the console, I can show you. If you just let me exit from here. Okay, if you say scoop to exit Zookeeper, you can just press Control D. Okay, if you say scoop space help, you will see the all possible options here. All right. Okay, if you can say export, help export, let me show you. All right, so you can push the data to Hive, and all right, there is, yeah. All right, so there is a syntax here as I am showing you. So, okay, yeah, here it says import. Okay, yeah, actually when we say import, so we have to see the import, not export, because we are sitting on the big data side. So import means bringing data from MySQL into the Hadoop side. Okay, now you can see it provides a way to import data to Accumulo. All right, and you can see that Hive as well, you can import data to. You can see HBase, it can import to, and that's it. All right. Okay. You can specify in what format you want to import data, whether parakeet file, Avro file, sequence file, text file, and so on. That's all. All right. Okay, so that was about Scoop. I just wanted to show you. Those who are interested in actually doing it, take a look at the video from the other class. That should be good for you for importing data. All right.
the script that is provided in the slides very much works. So you can use the script out of the box. Okay, all the commands provided in the slide actually work, so you can try those. All right, should we proceed with the next topic and take a break? All right, break for 10 minutes. Back by 9:50 p.m. IST. Okay, so Michelle, instead of using man minus k, try, because man minus k is a different thing. You could say scoop help import. All right. Okay, I'm going to increase it to 9:51 p.m. IST. All right. Thank you, Christine. All right, so should we start, everyone? All right, good, good. All right, so I think there were a couple of questions not answered. Could you just paste them again? A question from Kamal. If I'm correct, in MR, we can't be sure of mappers, but here we define minus M2. All right, good point. So as I was telling you that generally we do not specify number of mappers, right? By default, based on the input split, okay, which is decided by input format, number of maps are decided, correct? Here, why is it that we are splitting? Why is it that we are enforcing number of mappers, right? So I'll try to explain this. It's a very good point, and it's something worth noting it down. So why are we are enforcing the number of mappers? Okay. So question is, what is it that we are dividing? What is it that we are dividing? Okay. Quick answer is, what is it that we are splitting amongst okay. Quick answer is that the IDs, right? The values from ID column of MySQL table. Yes. Okay. The values from the ID column. We are saying some of the IDs the rows of these IDs would be copied by this mapper. Rows of this IDs will be copied by some other. All right. So the input to MapReduce is the list of is the file containing the IDs of table. So the way we earlier were dividing the actual input uh, data, here when Scoop starts the process, it creates a temporary file containing only the IDs from this table, and then let let that be divided. Now this file containing the IDs may be very small. Okay, it could be very small. Like in our case, we have only 10-15 records. Okay, we have, I think, 6-7 records. Yes, that's the I generally we have a primary key. So yes, generally the IDs is primary key. Okay, now it could be very small. Therefore, we might have to emphasize, because 128 MB block size is too big a number for only the IDs. So the even gigabytes of data even hundreds of gigabyte of data would hardly have few MBs in the IDs. Therefore, the file that will be formed only out of IDs might be, say, 10 megabytes or so. Therefore, it is required to enforce number of mappers. Okay, did I make sense to all of you? Otherwise, if you do not specify number of mappers, the chances are that it will try to do it only using one mapper. Good, good. All right, very good question. Any other questions did I miss? All right, I'll just go over Flume as well quickly. And I strongly recommend to everyone to go over the Flume class from my usual one to get the complete picture of Flume. I'll try to go over quickly and see if we can understand it. And anyway, the similar mechanism I'll be discussing while we do the Spark streaming. Okay, so nothing to panic. The overall idea about this session is to give you the understanding of the meaning of what does this Flume tool do. A question from Kamal. Also, can we partition ID in particular mapper? Mm, Not really. We can't specify so easily the partition, the specific IDs in the mapper. The general way is to divide the file in the usual way. Okay. All right. Very good question from Babu. How does Scoop handle incremental export? Okay. Incremental exports are generally handled based on first defining a column on the basis of which uniqueness is ensured. Okay, so it basically considers, if you take a look at the import, there is a, it says incremental. I'll show you that. All right, just give me a second. It's a good question. And all right, there is yeah, here. Okay, so yeah, so there are two incremental ways of importing data. Importing, when you want to import data from MySQL here, and that MySQL data is continuously being appended or incremented, you use this flag called incremental. Now, you have to specify either you want to use append mode. In the append mode, the ID column is verified and new IDs are the only one that are copied. In case last modified, in that case, the data is ordered based on the last modified, and then only the data that is newer is copied. Okay, I'll show you some more. There is a last modified column which we have to specify. All right, there is a last modified column that we need to specify in case we are saying here last modified. Okay, here, this is the one. So we have to specify that the last value that we have copied earlier was this much. Copy only the data bigger than this one. Okay, so if you are specifying import type as last modified, then you have to specify last value. Otherwise, you can simply say append, in which the data that was not copied based on the ID column will be copied. All right, was I able to answer your question, Babu? All right, very great set of questions. And all right, Kamal, was I able to answer your question regarding particular partition ID? All right, great set of questions. And all right, so that was about static, kind of static data, comparatively static data. What if, let's take a scenario that you are running a company whereby your overall web servers are multiple. Think about the companies like Google, or not Google, let's say small e-commerce companies, say AliExpress, or they say Dell. They also have a good e-commerce presence, online presence. Now, to handle such kind of load, such kind of e-commerce website, you would generally need many web servers, correct? Many web servers running the website. Some of the users go to one web server, some user go to another, and so on. All these web servers keep on noting down what all pages are being accessed in the form of logs. Now, okay, so let's say there are many machines which are creating logs parallelly, and you want to continuously pump the data to a central place, right? So I'll give you a good analogy. Um, at Amazon, as I was explaining to you, there are people who are always on call, and as a thumb rule, almost everybody does the on call so that customers do not face any issue. Okay, everybody does the round robin way. Now, when you are on call and you see an error, okay, so how would you see the error first of all? Because there are, say, 20, say 60 web servers running continuously, okay, and all 60 are generating the logs and errors. Now, these web servers, if they start saving the logs in a database, then the response time will go drastically low and they will be overloaded. So what we did at Amazon is that we copied continuously these logs to a central place. Okay, so continuously these files are copied. The data, as in when somebody appends to the file, the same data gets copied to a central place. Okay, and that's exactly the use case of Flume. Okay, so that the data is quickly available at a central place, and it is done in a very continuous manner. All right, so for that, that's exactly the case what Flume caters to. Okay, that's exactly the case Flume caters to. So Flume basically is a distributed, reliable, and available system for efficiently collecting, aggregating, and moving large data from many different sources to a central data store. Okay, so the way we do is we installed Flume on many machines, okay, and let all these Flume agents push the data to a central place. And what's the central place generally? It is HDFS. Okay, so let's take a look at the Flume agent. Flume agent is made up of source, sink, and channel. All right, why there are three parts? Imagine if you look at your USB cable, it's actually the way Flume agent is designed. Flume agent is a software component which has three parts. One is source, sink, another is sink, and third one is channel. All these three can be replaceable models. Okay, imagine a wire USB cable in which you can replace both the ends. Okay, you can change this kind of USB to USB 3, or say the say the port like what do you call VGA port, or anything else. The sink could be the different kind of chargers, and so on. So basically this architecture whereby source and sink and channel could be replaced and configured makes it possible for Flume to be very much flexible. let's say here, let's say source could be you're absorbing data from web server logs, and sink could be that you're pushing the data to HDFS. Okay, if there are, let's say sink is HBase, so and source there are, let's say there are 4 source types and 3 sink types, you could actually create 4 into 3, 12 kinds of wires, 12 kinds of agents, right? That's the modularity does. So you can do a lot of permutations. All right, so that's how it has been designed. Okay, this is how it has been. So agents can be chained together. One sink can push the data to multiple sources and so on. All right. So if you basically arrange this Flume agent in this way, you can actually create very fault tolerant way of collecting data from web servers to the central base. Okay, let's say this machine goes down, this machine goes down, this will anyway reach till the destination. All right, so there could be various kinds of source. For example, tail minus f. What does tail minus f do? Anybody? What does tail minus f do? That's correct, Dheer. That's correct, Hari. Continuous log. Tail minus f is basically multiple people, if multiple people are writing to the same file, okay, multiple people are writing to the same file, we could, sorry, if a file is being continuously uh, uh, updated, okay, we could see the last recent changes, okay, continuously. Tail minus f makes it possible to read continuously. Okay, syslog is another command, another daemon, which produces the log of the system. Log4j is a standard Java logging system, so it can gather the data from there, right? Using various kinds of scheme, you could form various different kind of um, mechanisms. All right. All right. So here I'm going to, take a little bit time, and so first you define your. It's also available in this folder called data flume. All right. Let me show you this part. All right. This is kind of required. All right. Let me copy it from Hadoop. Kamal's question is, we can use Flume to import RDBMS data to HDFS? No. Flume is for continuous data and generally from the logs. Also, there are quite a few logs available, quite a few sources for Flume available. Okay, let me know. Flume sources. All right. You can see all kind of sources that Flume can absorb data from. Okay, where is that? I'll show you the list of. You can see the kind of sources it has. It can absorb the data from Avro. Okay, you can see Avro, Thrift, Java Service, and directory source. You can see it can absorb the data from Twitter. There is a Kafka, Netcat, and there are syslog, HTTP service, whether it's binary data or JSON data, stressed, and you can see that. So there are quite a few different kind of sources that are available. but I don't see a relational database anywhere. So it can read the data from these various sources and save data into various things. All right. So you can also do this. So I have the same data is available in /data/flume. Okay, you can copy from there. I have also copied from there, and here we are. So I have created here the Flume folder. It contains the same data which I have mentioned there. And I'm going to show you what is there inside this conf. You can see these are the various, here you give the name to the agent. All right, why are we doing this? I'll explain. So for every machine, you will have one agent running. On every machine, you are going to run one agent. You will give the name every agent one name. All right. Now, although what we could do is we could create different Flume dot properties and ship everywhere to the all cluster, copy it everywhere, different. If you have 30 machines in your network, create 13 configuration files and send it to all 30. Okay, if you have 30 machines, copy create 30 Flume.property files, ship it to all 13, and then run. But that could have been very much unmanageable. Instead, you could create one file and give 13 agent name A1 to A13. All right, and you have the same configuration everywhere. All right, and once you're done with that, once you have defined that who are your sources and then details about each source, here we are reading data from, we are going to listen for data at this port. Okay, this, when we are saying netcat, the source is going to listen at this port, and we will basically read the data from that port. All right. So when we run this agent, it's going to wait for this network port called at 44444. All right. And then when we write the data, it's going to sync the data at this place. We are saying the sink is HDFS, and this is the location in the sink. All right. So I'm going to use this one. You could use some other port. All right. So if you want, you can use some other port and give the correct location for yourself and use this. All right. So I'm going to, all right, here we go. I'm copying my configuration here. If you want, you can copy the same configuration. All right. Or okay, Swan's question is, does it provide guarantee of delivery? What if Flume agent get crashed, and how we can monitor automatic or manual? So there are ways of monitoring services on every machine. Okay, so generally we use those standard tool. I'm not able to recollect right now, but there are many tools to watch your servers. All right. So I'm going to use this one. Let me, all right. So I've copied my configuration in this. Although same is available at here. Okay, so this is where we have I have created my Flume folder. All right, and a better idea would be that I copy this Hadoop fs copy from local Flume to /tmp. Okay, so I've copied this whole folder, Flume folder, to /tmp in HDFS. So you could use fs copy to local /tmp/flume. Okay, you could use this command to get this data. All right. So the configuration is available at that location. I have copied it there. Modify the configuration to fit you. All right. There's one crucial part I forgot. And thank you, Dheer, for reminding me that. So question is, what happens if the sync is not available? In this, we talked about source, we talked about sync, but we did not talk about channel. Okay, what does channel do? Channel takes care of differences between source and sync. While in the long run, source and sync are kind of doing equal job. While sync is absorbing data 60 MB per minute. Every minute it writes to the disk, and at that time it can write 60 MB in a minute. While source is generating 1 megabyte per second. Although both are same, but question is, by the time sync is busy writing to the disk, who is collecting this incoming high data? It is this channel. This channel is where the data waits. In case channel is full, the source will not be able to absorb the data. Therefore, you will have to create the channel such that it has a decent capacity. If your channel is really huge, the chances of stale data are higher. If channel is smaller, then okay, if the channel is smaller, then the chance of dropping the source data is higher. All right. So if source is really generating data faster than sync, then you will have to figure out a channel which persists the data into the local disk and then sends via sync. Okay. So here the assumption is that in the long run, maybe in a day or a two, the sync will catch up with source. Okay. If the source is really faster, then you can't really do much with source is really faster than sync, then you will have to figure out a sync which is faster. All right. Good, very good question. All right, so we have created this configuration file. We have defined our channel, source, and sync. Now it is time for running it. Okay, now it's time for running it. You might want to change the port number as well as you might want to change this username in the URL of the file. Okay, so let me also open my Hue. Okay. Where is Hue? Okay. Question from Hari is who decides this port number? It is our choice. Okay. We are saying that we are expecting data at this port. So our source is going to wait for the data to come at this. It is something to do with the source definition. It is the server guy who will tell you what kind of source they are going to give us data at. All right. So right now what we are going to do is we are going to create a service which listens on our port and we're going to write data to. and then it's going to push it to the HDFS. All right. So what is the location we are trying? We are trying for Flume. I'm just going to delete, or maybe let it be here. Okay. This is the ouch. What happened to my? Yeah. This is where, wow, there are quite a few files. All right. There are quite a few files, and now we have deleted it. So right now it contains nothing. Now I'm going to open one more terminal. So we have two terminals open, one for running the agent, other for producing data. All right, going back to my slide. So we first created this configuration file. You can copy my configuration from Hadoop FS copy to local, this one, okay, and modify these locations. And once you're done, then you run this command at one of the locations, okay. All right, let me fix the formatting. It says flume ng, and then, okay, so this is the command that I'm going to use. All right, so here we go. Okay, so I have to go into the flume folder and then use this. So what I did was, after this, I said cd flume, and then I run this. Okay, now let's take a look at what does it say. It says that the port is busy. Somebody else is running on this. Unable to bind the port, it's already in use. Okay, no worries. Let me change the properties. I'll just use nano so that you can also use the same one. You can see I'm going to say use 40. All right, because no two processes can listen on the same port. All right, so here is a process which is running Flume agent and continuously going to pump to HDFS. Right now, it is waiting for me to write something onto the port. Okay, you can see that this is just waiting. Now let me go to another terminal and log in. Okay, I think I sent only to Dheer. Let me send it to all. Okay, so all right. So you might have to change to a different port. If you can announce your port number, I'm using 44440. All right. So here is my Flume agent running on the first tab. Now I'm connecting to my Flume agent by saying localhost 44440. Okay. Here I'm going to write some data, and let's take a look. All right, where is the file browser? You see, temporary data has come in here. If you go into this, we just typed something and it has come here. And you can see that it is bytes writable from HDFS. Okay, this is a sample text. All right, now going back here, you can see this. Data is continuously going into the file system. As I'm typing, the temp becomes this, and this one is here. All right. NC localhost 4440. All right, I think we need to refresh it. So as in when we are typing data here, it's going into the HDFS. Who else is able to do it? So you can see this is a sample text. All right. So all we did was very simple steps. Okay. First copied the config file, cd flume, and did nano conf/flume dot properties, edited the port number and edited the HDFS location. Okay. And then we ran this particular command. Okay. On another terminal, okay, we ran nc localhost and the port number 44440. For me, these were the port number. Okay, added the port number and HDFS file location. All right. All right. Is anybody else trying? So we copied the Flume folder which I have given from the TMP folder. I have kept my copy there in the /TMP. Then once you've copied it to local, you go into the Flume folder, then edit the flume.properties located inside conf/ in the current directory, and then edited the port number and to something other than what I'm using right now. Okay. And you don't need to create Flume directory. You can just copy the Flume directory in your home folder using copy to local, and it should work fine. So when you copy, it'll copy the directory. Yeah. So is everybody with me? Is it clear? Should I move forward? Or do you want to give it a try? Okay, Kamal is trying there. All right. So Christine, you are able to do it? And Rana, you also? Okay. Wow. Rana is able to do it. Great. So never mind. So in case you get stuck, let me know and take a look at the video. It should not be very difficult. All right. It should not be very difficult. And all right. So that was a quick overview of Flume. All right. That was a quick overview of Flume. Okay. All right. Now, a very small topic, and although it will be used in a project scenario, but it's not a very difficult topic. All right. So, all right. So far we have talked about importing data. So today we talked about Zookeeper, how to coordinate between various distributed processes. In case you are running your MapReduce, sometimes you may want to use Zookeeper, but if you have to coordinate too much between your mappers or reducers, it it impacts the overall performance of your MapReduce very badly. Okay, so Zookeeper is good amongst the distributed systems which want to have a concurrency and configuration exchange. All right, so after Zookeeper, we talked about Scoop, and then we talked about Flume. All right, the sure, Kamal, I'll try. Okay, so I can help you run the Flume after the class. All right. Is anybody else wants help other than Kamal? Okay. Okay. Dheer also wants a help. Okay. So, all right. Let me see. Kamal, is that okay if I think it will just take, it'll just take 5 minutes of everybody's time. And I'm sure everybody else will also be facing the same problem. Okay. So let me see if we can do it now. All right, so I'm going to stop share. Yeah, you can share your screen, Kamal. We can just fix it now. Okay, because I'm sure if you're facing problem, others will also be facing the same problem. Okay, so yes, okay, now show me the other terminal. Where are you running the agent? The third one, next one. Yeah, this one. I can't see it. The third one. Okay. All right. I got it. So go up and run the command again. Go press up arrow key once more. Yes. Now run that command, please. Okay, so let's see what happens now. I think you're writing to somebody else's port. Okay. And press Control C. And let's see. Show me nano space flume slash conf slash conf slash flume dot properties f and press tab. Just you could actually say f and press tab. Not there. I think you have typed the spelling wrong. You forgot the L. Okay. No, you can. Right. So you can press Control X. No. N. Yeah. So just press up arrow key. All right. Slash F. Press tab. Doesn't work. Tab isn't working for you. Never mind. So you can type this. All right. So you are at good. You are at the right location and good. Good. Now I think everything is okay. So you are at the correct port. Go up. Type nc space localhost. Enter. Type something here. Or just copy paste. Now go to hue. Not this one. Go up. Press the Leo Kamal. Yeah, that one. Okay. Sort the data by time. Okay. And also show me the screen. Show me the third tab, fourth tab actually, fourth tab. Yes, fourth tab. Show me what's going on there. Yeah, go up, go up. It says that you do not have permission for this user to write /users/Leo and flume/web data. I think you'll have to create flume/web data. Okay, that's all. You have to create this parent folder. And also there is one big mistake there. You have to say user, not users. There you have mentioned /users in that file, in the config file. If you take a look in the config file, you have mentioned /users. Okay, that's the only mistake. So if you go in the second tab, do the nan, or you can just press Control C on the fourth tab. Fourth tab, press Control C. Control C, Control C, yeah, there, and okay, edit the config file, correct it, and that should be good. Okay, if you do nano space conf/flume.properties, all right, I think that will be okay. All right. So in case you get stuck, let me know. We can fix it together. In the flume.properties, the location is wrong. Instead of /users, it has to be /user. All right. Okay, good. Anybody else facing a similar kind of issue? Okay. Okay. So what kind of error are you facing there? Have you verified the location of the file and the port number? Okay. Missing option N. So when you are running the agent, it is asking you for. So are you using this command? Can you try this kind of command again? Maybe it has gone into new line. That's why it has faced the problem. Okay. Most likely after the name, it must have gone into new line. That's why it's trying to only do the first half. Okay. Try with the whole command in a single shot, and that should be good. Okay, Dhir. If you get stuck, just ping me. We'll take a look at it. Just send me the screenshot, and then we'll take a look at it. Unknown host exception. Unknown host exception. All right. Here in the host, did you say local host or you have changed it to something else? All right. Let's try to do it over the after this class, maybe tomorrow. All right. All right. So I'll just go over Uzi quickly. All right. So when you have a larger project, okay, let me show you an example of the project. Okay, so not here. All right, so let me try to explain. So in a larger project in Hadoop environment, you generally have many parts to it. Okay, let's take a case of typical predictive analytics problem. Okay, in a predictive analytics problem where you do the prediction based on the past data. So what are you going to do is, let's say you first import the data using some part using Flume, some part using Scoop. And once the data is in the HDFS, you may want to clean the data using a MapReduce process. Okay. And okay, so okay, So let me try to draw it as I say. So let's say that there is a data coming from, let's say, Scoop and Flume. These are raw data you are pulling into your HDFS. This is your HDFS. Okay, this is a typical example of predictive analytics. And in predictive analytics, we are, let's say, about recommender. Okay, so in a very classic case, what happens in a larger project, that you'll write your script which will pull the data using Scoop from, say, SQL, certain data which is there in the SQLs already, some data from, say, unstructured data into HDFS, right? Let me just draw two HDFS folder. Okay, this is folder 1, folder 2, and so on. Now this data which we have here, you might want to process using one MapReduce, and so this get processed by a MapReduce. This get processed by MapReduce, and this get processed by using Hive. Okay, and then once we have, again, all right, and then maybe we would like to join both the data sets again using, say, Hive, or maybe this is partially in Pig and Hive. Okay, so raw data from SQL, we are using Hive to first clean it up and keep it. And then there is parallelly some data coming from the real production environment, the logs, we are pulling that from there. Okay, and after we have cleaned up at both sides, then we have joined it again using Hive, and then we do the real predictive analytics and using, say, Mahout. Okay, and Mahout's result again go into HDFS. Okay, and once they are kept in the HDFS, some of the results might go into web servers database. Okay, let me be very clear in this. What is it that's going on? Okay, let me take a very concrete example of the recommender which I have written for InMobi. Okay, so what InMobi does is InMobi displays this ad on your mobile devices. When you're playing a game, there is a browser on the game that shows an ad. Okay, there's a browser, there's a small browser widget which is displayed there while you're playing any game. So generally, InMobi displays an ad over there. Okay, and before a ad is displayed, a request goes to InMobi, and InMobi records the request parameters. In that request, it is recorded that you are playing a particular game. So InMobi, the company which I was working before Amazon, so InMobi knows all kinds of users' habit, that you were playing this particular game when a request came to InMobi. Okay. Similarly, somebody is playing Fruit Ninja, somebody playing Temple Run, somebody, and so on. So we have gathered this data, that who is playing what at what time and for how long and how many times, right? So we have this record that who was playing what day, what game at what time, and based on this, we've basically figured out who likes, who is addicted to which game, or who likes which game how much. And how did we compute? We first took this all logs. Logs are in the form of plain text containing raw data. We parsed it using our MapReduce jobs. After parsing, we removed the redundant data from it, and then we basically summed up all total duration of the game or total number of times you have played a particular game. Okay, total number of times the game has appeared in your history. So for every user, we basically grouped the data based on the user ID and counted number of instances the game is being played. And once we did that, the next step I did was we normalized it so that we rated that this user plays this game this many times. We normalize the data from thousands into some value between 0 to 5. Okay, so now we had a very clear data that Christine plays, Christine likes this game, Fruit Ninja 5. Sabanand plays, likes Temple Run 4 out of 5. And Sabanand likes, say, uh, Subway Surfer 1 out of 5. Okay, after this part, okay, so after this part, okay, once we had this clear picture, once we had joined all did all kind of cleaning of logs, we were able to say that this user likes this particular application this much. Now this data we fed to Mahat, and Mahat gave us very clear recommendation that give these 10 suggestions to Sabanand and these 10 suggestions uh, to to say mm, Rebecca, and these to Catherine, and then the, these to Kamal. So those recommendations we pushed back to the web server, and on the web server, when users requests were coming, we started showing them that you may also like to play this game. Okay, just based on each other's habits. So we clustered the users together based on their playing habits, and then we started showing them the recommendations. So that was very successful recommendation. Okay, so the important point which I'm driving here is that you have to create this kind of flow. Okay, generally in a production environment you have many moving components, and these jobs, some of them are continuous, some of these are batch wise. So for batch wise, you will have a big flow in which the processes need to be triggered based on the data availability or based on the time availability, and that's where the Uzi comes into play. So we used, instead of Uzi, we used Azkaban scheduler that time, but then we moved the whole flow to Uzi later on. All right, so Uzi makes it possible to create a kind of project plan in the form of directed acyclic graph. Okay, and this is the kind of XML it creates under the hood. Okay, just like you define Ant build files, Maven build files, similarly you define the Uzi build files. It provides you a way to fork the flow, and you can run the project in this way as mentioned in this. Okay, take a look at it. It should work fine. All right. Also, if you are not a big fan of trying it out, a big fan of typing, you can try the Hue workflow. Okay, you could try the Hue workflow. It's a very clean way of defining the, it's a very clean way of creating the big workflows. Okay, let me see if I can show you. You can say editors and workflows. All right. So you can say here, create a workflow. Okay. So here you can see that you can define your workflow here. Drag and drop, let's say Hive. So you provide your path to script, the path to your the script. First upload that script in the HDFS, put it here. Okay. So I'm just putting, let's say this one, and you can alternatively specify this one, but you don't need this. I'm going to remove it from here. I'll just say this one. Okay, so I can drag and drop everything. So this is my Hive script. Let us say that you want to execute something parallel to Hive. Let's say pig script is what you want to execute parallel. Okay, I'm just selecting some random things for the demo purposes. So as the process starts, on one end, one job, pig script will be executed. On other hand, Hive script will be executed. And then once both have finished, we could say that please execute my Spark program, or scoop will go, let's say, before pig, or let's say before Hive here. Okay, we could say something like this. And then let's say my MapReduce job. Once everything is done, I would like to execute my MapReduce job. Okay, we could select our MapReduce workflow and so on. All right, so that's how you generally create your project workflow using Oozie. All right. Although the example which we have given in this is actually, this Oozie examples is a very comprehensive project example. You can use that example project in most of your production environment. All right. So that's pretty much about Oozie. Okay, that's pretty much about Oozie. Using Oozie, you can create the project workflows. All right. So as an assignment, I would recommend that you try Scoop and Flume both on the sample data, and that's kind of assignment you should do at home. All right. In case you get stuck, please drop us an email, and we will try to help you out. All right. Okay. So that's pretty much for today. Tomorrow we are going to start with Scala and Scala and the basics of Spark. So do not miss tomorrow's class. It's very, very important. All right. So do not miss tomorrow's class. It's quite important for tomorrow, because we are going to kick off our Spark tomorrow. Okay. It's a very important topic that we are starting tomorrow. All right. Babu, Christine, Dheer, Hank, Hari, Harsh, Jay, Kamal, Leeladhar, Madhu, Michelle, Mrityunjay, Pankaj, Rana, Rebecca. Okay, for a moment I thought I put everybody to sleep. Okay. Okay, so it was a good session. I saw that some of you have actually finished this Flume already. Okay. Okay. All right. I'm happy, Hari, that. Okay. You like that? All right. Hank, just give me a ping if you have a question. Okay. I would love to have one-on-one. All right. If you are stuck and you are feeling a little lost, feel free to give me a buzz. I would love to help you out. All right. Thank you, Kamal. Thank you, Harsh. Thank you, Christine. Thank you, Dheer. Good night. All right, everybody. Okay. Thank you, Sasi. I'm happy that you really liked the session. I look forward to see you tomorrow. Okay. Bye-bye.